go ahead and get started. Good morning, everyone. Thank you for joining us for the solar design and installation webinar. This is part 2. Just to make sure you guys are getting the most from the webinar, we really encourage you to take as many notes as you can, submit any questions that you have, and then ask as many questions as you want. You can do that in the chat side. If you go in and just type your question, we'll be able to see it. We'll answer it periodically throughout the webinar or at the very end, so don't think we're ignoring you. My name is Carly. I will be the host. I am a marketing and event strategist at Enertech. Yeah, like I said, to make sure that you have audio, you want to make sure that your phone is either connected or that you've connected through the webinar itself. If you see the screens moving and there's nothing, please let us know, because sometimes you will miss it throughout the webinar. And then if there's anything else, there should be a little button that you can raise your hand and we can go to you directly and help you out. So let's begin.
Good morning, everyone. Hope everyone can hear me okay. My name is John Pendleton. I'm the senior trainer, and I also work in tech support here at Enertech. If you need to contact me, here's my contact information. At the end of the webinar as well, we will have that contact information again. And just for your knowledge, these trainings are recorded. And at the end, if you're signed up through GoToWebinar, it'll be in your video library. And if you don't have an account with GoToWebinar, then you can also go visit our YouTube channel, Enertech Unversity, and we will download or upload those videos to YouTube as well, so you can see them there. For some reason you want the PDF form of this training, you can definitely shoot me an email or give me a call, and I can send you a PDF format of them. With this virus and everything going on, I'm working remotely, as most of us are here at Enertech. So for some reason I don't answer. It forwards it to my phone. So leave me a message and I'll give you a call back. So just know that you can go back and look at this training later on. Kyle Smith's going to be helping us out today as well. He's our solar sales and energy storage manager. He's taken that position about a little over a year or so ago when we started handling more of the solar stuff. So he does a lot. He's out of the office quite a bit as well, site visits and helping on installs and that kind of thing. So if you need to get a hold of Kyle, probably email is going to be the best to get a hold of Kyle. You can try the office and leave a voicemail. He can get that as well, but definitely shoot him an email. Then we've got a design team to help you guys out when you're designing these solar arrays. And we have Jim Cusack. Some of you may have seen Jim Cusack around. He was our Minnesota territory manager, and he's done a lot of trainings and such. So he's got a vast knowledge with our geo units, and he's helping out with the design as well as doing some of the trainings. And he's probably sitting through this today with us. We've got Zach Slatton as well. He does a lot of the help with the installs. So he's out in the field quite a bit. And he gives he's Kyle's right-hand man. We've also, in the office, we've got Angelique Wood and Jeremy Vonderhaar. They actually work back in the office with me, and they do designs on the solar. They'll pull up Aurora and figure out how many panels you need and where they're going to go, and kind of figure out your array. So we have definitely some help for you as far as the design side. We'll also offer some sales support. Obviously, we are offering the trainings, this being the second of a 6-part series. This 6-part series, once we get past this coronavirus and stuff, we can also do this training as like a day-and-a-half training or a 2-day training in person. So if for some reason you guys want to go through it again in person, hopefully this virus stuff will end soon and we can get back to our normal lives. And but we can do more online trainings if you need more. or we can definitely do some in-person trainings. Obviously, we offer marketing for the product. We can get you in contact with Carly or Mallory in marketing, and they can definitely give you a hand on that. And then customer service is normally where we order our parts and things through. So if you need anything from customer service, you can call them on the Fast Pass. It's a direct line to customer service at that 618-664-9011. Or you can email customer service at customerservice@enertechusa.com. Some of the services we offer for our solar is we have residential and commercial solar arrays that we've designed and installed at this point. We do have job site delivery. Normally, it's got to be somewhat close to, our area or in Illinois here, but we will arrange job site deliveries. We will help with your SREC services. We'll help obviously design your roof mount or your ground mount, whichever you're using. And we will offer in tech support some installation help or installation support. We do have obviously training again, and then our design services. So we've pretty much got you covered on the solar. So if you're not real comfortable, we're more than willing to work with you and get you up to speed and get you installing some of these solar arrays. This is the website, the secure site. You can go on and register here on the support and secure. Basically, you fill out all your information, set your password, and we don't sell your email or give it to other companies to send you a bunch of junk. So you can register. You don't necessarily have to, but you can go to this professionals tab and click on that professionals tab, and you can get into some of the design forums. There's one for geothermal and there's one for solar. So pick the one that you're working on, fill out the information, and that's how we'll get the design process started. So always go to that website once you know a lot of your parameters, and we can go ahead and get the design going. Basically, the importance of the design, if you don't design it properly, it's going to make it a lot more difficult going down the line. So, a detailed design, it'll make your installation a lot smoother, a lot quicker. The labor and material will be less. As you do, maybe the first one, it may be a little bit of a struggle for you. But as you do more and more of these, you'll get better and better and more efficient. Your installers will get better because they've done a few of them and kind of know what's going on. So as you do a couple of these, it'll actually lower the installation costs. You might also see where, hey, maybe I didn't need this bracket or that bracket. So, your material list could also go down as well. Obviously, if you design it properly, it's going to function properly, which in turn causes less site visits to the site. Looking at the job or going back out there to redo something, you're going to have less site visits, so that cuts back on, again, installation costs. Once you design that system, you can relay that information on the consumer, and then they don't have unrealistic expectations. They know what they're going to get into before it's even ever installed. Obviously, we want to look at utility and code requirements when we're looking at this design. So, if the utility company says you can only have a certain amount of percentage of your power through the solar, we'll take that into consideration. We don't want to build a system that's, not going to work because the utilities won't allow it. It's just wasted time to design it all that way, and then at the very end go, hey, we can't use it that way. So make sure you're always working with your utilities and checking on your code requirements. Make sure you have a good relationship with your utility company. Around here, we have Ameren and Missouri Electric Co-ops, and but there's Minnesota Power, there's WEC Energy Group. So just wherever you're located, make sure you're checking with your utilities. And if you're not the most comfortable with it, you may want to talk to your TM. He may have a connection with your service provider in your area, your co-op, or the power company. So they may already have a relationship and be willing to talk to them and see what their different codes and things are. So definitely check with your TMs. They'll have some information, I'm sure, for you. Make sure you know your tariffs, what your feed rate and your buy rates are, and then what the true update is. These power companies, they can either do a monthly, a quarterly, or an annually look at the power that you've used and kind of judge it off that way.
So yeah, the true update.
Add on to that, Kyle?
Yeah, the true update is really like cell phone rollover minutes, if you think about it like that. So that at a certain point, whether it be could be daily, monthly, quarterly, but it's when the utility is going to true you up, and meaning that it depends on where you're at in the country or which utility, but it just means when they're going to start you back to zero. So your credits that you've built in kilowatt hour credits are going to go away. They're going to let you keep them until, say, the end of the year, and then they're going to start you at zero. Some utilities, I can think of one in Kentucky that's jaw-dropping, but they even send a check for any overage that you do have. So that, just to clarify, that true update is used as a start to zero date. So if you're able to do annual net metering or monthly, you just want to be able to make sure that you're playing to the advantage of what the utility gives you, so that you're not wasting kilowatt hours in your design, which, if you're wasting kilowatt hours, that is affecting the return on investment for the consumer. And then the size limitations, I'll just finish that one as well there. Size limitations means that the utilities could have caps on size limits of DC or AC. So that would tell you a whole lot about what you can design to anyway. So there's no reason to design a 20 kW system if the utility is only going to let you do a 10. So just part of the conversations to have with the utility to make sure that you're playing by the rules and you're not wasting any time without having to go back and fix something. The last two parts on this slide, I'll just finish this one, John. So the best system for the utilities solar policy, and that one is really something that we push pretty hard. It really depends on the utility and what they offer. It just all depends on what their particular rules are and playing to the advantages that they give us. So if they say, I've heard of some utilities, for example, having thresholds for systems where they have allowing for net metering. So there's one co-op I can think of that they have net metering for anything up to 10 kW AC, which is the inverter. And from that point on, their incentive, if you will, their net metering incentive goes down to more of a solar tariff, and where the retail buy for kilowatt hours is, let's say, 13 cents, and the utility is going to give back the kilowatt hours at wholesale rate, of which they pay for it, at like 4 cents. So there's a sweet spot there that we just want to bring to your attention, that it may be best not to get to 100% of coverage whenever you might want to go for a system that's only 80%. It makes more sense for the consumer to do so. And then lastly, this affects utilities determine where you can locate your disconnect or safety switch. We will talk about that one later on towards the end of the presentation today, but that might limit, that's just something you want to pay attention to. Some utilities are pretty strict with where the disconnect or the safety disconnect can be, and it may have to be within 2 feet of the meter. If that's the case, I can think of quite a few jobs where, you know, we would have to cut up concrete or bore underneath a parking lot or whatever it may be, and that can really affect the ROI of the project, clearly. So it's just something to be aware of before you starting a design on just a little bit of a strategy ahead of time. John, you can take it from here.
All right, thanks, Kyle. So basically what's needed on the solar design form that's on our website. Obviously qualifications, make sure you're always getting the customer's utility bill. Once you get that kind of utility bill, it'll kind of show you that they are, you know, interested or serious about going forward with the solar. You hate to put all that work in and they say, well, we just kind of wanted to see what it was going to cost. You know, so you wasted all that time. So you get the copy of the utility bill, you're kind of going to know that they're serious. Try to get a location of the meter, a picture of the meter, where it's located, whether it's, you know, inside, outside, on the side of the house, wherever it's located. Make sure you know where the main service is. Also, if you're going to do a roof mount, take a picture of the roof material. You know, is it a metal roof? Is it a shingled roof, rubber roof, whatever that may be. But make sure we always note what type of roof, if it's going to be a roof mount system.
Just to expand on that one a hair, that this is our solar design form by hand. So we have a hand copy that you could take with you if you went to a job site and met with somebody. So we, you know, obviously we have our online version, and then we have this handwritten version as well. And the idea behind know before you go is it's a lot different from other qualifications with a consumer. It's a lot different than any other industry, in my opinion, before you actually ever go to the job site. So right now, everyone could be doing a whole lot of consumer qualification and never leave your house. Why I say that is if they send you a power bill, they've taken the effort to go find it and send it to you, which means they're probably more serious. And then on the imagery, the images, if they send you their meter, a picture of their meter location and the roof and material, and their service coming in and where that's located at, the questions that you ask so that you know what needs to be done, they're really serious. So it helps so that you don't have to actually go to the job site to ever work on a design and a proposal, so that hopefully you can do basically a one-stop close, meaning that you can sell them right there on the spot and they're ready to sell and they're ready to buy. So there's just quite a bit of preliminary work that could be done without ever leaving your office or house.
System design, selecting roof or ground mount. Gather the information on the following. So we're going to have to check shading, any kind of obstructions, the meter location where you would like to locate it, best location for the inverter, and the router location. Those are all things you're going to have to take into consideration. Obviously, if they don't have anywhere in their yard to put it, then you're going to almost have to go on the roof. You know, you may also want to, you know, ask them about, you know, about where they would prefer the location to be, and then kind of take it from there and look and see if it will go there. Are there trees in the way that they're going to have to be cut down because there's too much shading, or are they already planning on cutting those trees down? So there's things we're going to need to know and look at before we just say, hey, we're going to install it right here on the roof when you got, you know, 100-foot trees all the way around the house. So we're going to have to look at all that kind of stuff so we can get the best performance out of our panels. Obviously, all these shading, obstructions, locations, they're all going to affect the system performance. So what's the best project in the performance versus cost? You know, that's definitely going to vary from home to home for sure. We do use a program called Aurora to design. On that program, when Angelique and Jeremy are working on it, it will show trees and things like that. If there's like a big tree in the way or something, you may get a call from our design team that says, hey, there's a big tree here. And you may say, hey, the tree's not there anymore. They cut it down. But that's little things like that they're going to be able to see on the design program. And they may call and double check on some things. So location, obviously, which area of the roof receives the best sun coverage. Obviously, we're not going to put any solar panels on the north facing roof line or on the ground, as we're not going to get any sun on that side. So if there's a south facing roof suitable for array, that's going to be the best. East and west are also suitable and will work. And then again, would a roof or a ground mount be your best location? So by looking at this picture here, let's say that this is the front of the house. You may want to ask the homeowner, is it okay if we put them on the front of the house? They may not want to see those panels on the front of their home. But if it's, if the back of their home is facing north, we obviously can't put them there. So either we're going to have to go with the ground mount or put them on the east and west facing roof lines. But definitely ask them that question. Is it going to be a problem if you put them on the roof? They may say, I don't really like the look of it. So definitely take that into consideration.
Good point. And then another thing, while we have this slide up, see the house closest to us, and then the house, behind, I guess, the neighbor. I guess that would be like west or something. But anyways, the house closest to us in this case is going to actually have more complication to installation, and which would actually increase the cost slightly. The homeowner may not pay more, but it may cost you more to install that project, just because there's more start stops. If you look at the rows, you have the panel up on the top right, and then you have the two panels on the bottom left. And in this case, it just makes you start your racking and over again, whereas the system in the rear back there is all one solid, I guess I'll call it a solid array, but notice it is all black on black and a connected array. So that one could cost a little bit less to install, and even in material, for just a comparison to expand upon what we talked about last week, as relates to price per watt and installation expenses.
Yep. Again, we kind of already talked about that, about where they're located, and then panel color preference by the homeowner. There's pros and cons of the black on black. They do have a lower output, but are better looking than the black or the white on black, I guess it would be. They do have a higher output, and I believe those are the black on white are better suited for if you have some shading.
So the efficiency of the it's basically that white backsheet, or the black backsheet in this case, takes away from efficiency. And so it basically makes the panel a little bit hotter. We all know that if anything is electric and it creates heat, we likely have energy waste. So we're creating a little bit more heat with black on black, and then a white backsheet lets that, it doesn't take as much heat, I guess, from the sun, and that's why they perform a little bit better. But black on black's generally about 20% more cost, because those are only available in the 60 cell size, which is 40 by 65. And again, black on black is going to be a black frame, black backsheet, and black cells. So they're triple black, and they look pretty good, and that's what you'll likely see. If we have to go with that 60 cell size, we'll likely see us push more black on black in that case. But we sell an awful lot of the larger 72 cell size, just because of the better price ratio.
Sizing a system. So understand that DC and the AC, normally we will oversize the DC over the AC by it's 125%. And that's for the inverter cost as well as the DC startup amps. Excuse me.
So, yep. And then, so that goes back last week on oversizing your DC is a range of 125%. I mean, it could be 120, it could be 130. But really that 125% is a good sweet spot. All our inverters, depending on the company that makes it, if they're single phase or if they're 3-phase or whatever it may be, they only make them in certain sizes. So, you know, single phase string inverters that we'll talk about later, they're only available in 6, as an example, 6 kW, 7.5 kW, or 7.6 kW, 10 kW, and 11.4. So, and then when you look at your DC side, you know, if you're using 370 watt modules and you have to use them in pairs on a ground mount, you're not going to land at 125% every time, is what I'm trying to say. And so it's just something that we try to aim for and get close to. What we have noticed here lately is that the inverter, if we have one utility that I can think of offhand that has a cap of 10 kW DC. So usually they're 10 kW AC, but it's their bylaws. It is what it is, because I personally disagree with that. But what we do in that case is we get as close to 10 kW DC as we possibly can, but then we use the 7.6 inverter that would bring us down a little bit. So what we're going to do is save you likely, you know, the installer pricing around $500 by taking the inverter down a little bit. But what we're also going to do is get that inverter to start up sooner in the morning and go down later in the evenings, which in turn is actually going to create a nice amount of kilowatt hours. So, you know, I think that a system range is around like 15,000 kilowatt hours a year that one was going to make. And if you used a 10 kW inverter on a 10 kW DC, you're only going to make maybe 500 kilowatt hours more a year. So it was very advantageous of us to go ahead and design in a 7.6 inverter for less money. It gets more startup amps in the morning to get the inverter turned on. And don't quote me on this, but I believe that DC amps, I think that an inverter needs 300 amps to kick on in the morning for a string inverter. And so that's, or maybe it's volts, I can't remember exactly on that one, but that's just something that we noticed, that it's smarter to go with a smaller inverter and don't waste the money to pair it up to the DC system size, unless somebody's planning on expanding in the near future with more solar panels, more DC. So then on the next one, this is a little very short equation that explains solar really quickly, in my opinion. So DC system size, meaning solar panels, the orientation of which they sit, and the inverter size equals kilowatt hours. Kilowatt hours are how our consumers' bills are made, and that's how we get rid of their power bill. So it's really simple. If you break it down, is DC system size plus orientation plus inverter size equal the kilowatt hours that we're going to make. So when we say orientation, I think the rest is self-explanatory, but the orientation means the latitude of where you sit. You could be in Canada, you could be in Florida, but just that, depending on where you are on the earth, depends on how we orient the panels to the sun. And then the azimuth is the east, west, or south, and we talk about that as well. So the best performance likely is the south facing, if at all possible. And then tilt is 0 to 45 degrees. We've done installs where we're completely flat, and then we've done 45 degrees, which would be like a, I don't know, would that be like a 13, 12 pitch? So it just depends on where you're at and what's going on with your climate of what's the best angle to go. 45 degrees isn't going to be very good in the summer months, but it produces an awful lot in the winter because the sun's so low in the sky. So as I talked about earlier, kilowatt hours then should reduce the somebody's electric bill. At least we're going to be creating kilowatt hours that at least will offset somebody's electric bill, but we may not be able to eliminate somebody's power bill.
Yeah. So sizing of the solar array. Step one is determining the actual annual electrical usage for the location. So that's when we look at that utility bill, take the total month usage and add those up and divide and get your average usage as well as your annual usage. Divide your annual usage by 1.4, and that's going to give you your AC system size. So 1.4 is the annual sun coverage, and it will vary by state. So you may want to check into that, make sure it's a 1.4 that you need to divide against.
John, I heard you hesitate there on that. We have a typo. I heard you hesitate there. I mean, I think you caught it already, but we have a typo there. That's actually divide the annual usage by 1.4, and that'll give you your DC system size.
DC, yeah.
That's going to be, which is going to be your solar panels. And that's going to be a rough guess. And we'll teach you how to validate that. So we have a correction on there, and our apologies on that typo. But that'll tell us our DC system size, and then our inverter size from there. We can kind of judge, well, I guess we have step 3 there. And that'll tell us what, if we think about the 125% rule that we were just discussing on the previous slide, that it's going to, if we divide it, so let's say if we have a microinverter set up and we have a usage of 16,000 kilowatt hours per year divided by 1.4, that tells us that we need about 11.5 kW DC system size. So, and then we divide 11.5 kW by 500, which is just a 500 watts. And for a microinverter, we'll talk about those later. But that's going to give us about 22.8 23 microinverters in that case. So we could potentially need up to, depending on wattage of those panels, up to 46 if those are low wattage modules on that particular case. But in a string inverter case, we could actually use higher wattage modules and one inverter to put more DC coming at that inverter on that particular system there.
So less panels, but
yeah. Microinverters, they don't love high wattage, but we'll talk a little bit later about wattage. A perfect environment wattage is not real. Meaning that there's only a few days of the year that the sun perfectly hits a module, that it can actually perform at its wattage. So microinverter companies really like to hit hard on that a panel doesn't really operate at the wattage that it says it is. So we'll talk about that after later, but we can probably move on from this slide here, John.
Okay. This is just a quick little sizing guide. We're not really going to cover it today, but it is something you can take a look at, and it will help you kind of walk you through a quick sizing for some retrofit of the panels and the modules.
I think this is a handout, Carly.
Yes, it is a handout. If you go to your side panel, you should be able to download it now.
Okay, great. Thanks, Carly. So there you go. Yeah, you can download it now. Excellent.
as well as that form earlier, that hand form that we saw a few slides back, but it was on for the design services form. That's also a handout, and it'll also be emailed to you after the session is over today. So you'll be able to get that as well. So it'll just give you, it's a nice workflow flowchart reminder of how to design a system. And really what we're trying to teach you today, I guess I want to make perfectly clear, is you don't need us. We can definitely help a lot, and we can work in a workflow with you to where we can design it if you give us a few days to do it. But you don't need us to design your systems. You can easily use what we'll get to PV Watts next, where you'll validate your handwritten DC system size and just double check your numbers, and you may move them a little bit back and forth, or up and down. But you don't need us to design a system. And we always want to help, believe me, but like I said, you just don't need us to be there or waiting on us to be able to provide you the information. With using PV Watts and a tape measure, you can do an awful lot.
Yeah, we'll see on this next slide. We'll kind of go through the actual PV Watts calculator demo here with Kyle. But you can go on here and basically see you can figure out your DC system size. It'll ask obviously your module type and system loss, tilt, and Kyle will go kind of all through that here. We do offer some design tools as well. Again, this is being your PV Watts calculator. PV Watts does have a calculator training, so you can definitely do that as well. Then we also use, we'll probably cover those after this PV Watts. I don't want to get you guys confused. So
I think I'll wait, John. We're moving a little slow on time here on slides, so I think I'm going to wait till the end to see how we do, and I'll just come back to it at the end for those who want to just watch a quick demo. But you can pretty well see by the screen here, and what you're going to go is just I suggest Googling PV Watts. It's an NRail, I'll call it product, and it's got a long domain name of its address. So then I would probably take that and just make it a shortcut on your browser. But what you're going to do is get your kW size. So if it's 12,000 watts, they want you to put in 12 kW in the DC system size. Enertech only sells premium modules. There's other module types available that we'll talk about later as far as the construction goes. But we only sell premium. And then typically sizes or losses, rather, system losses are around 5%. As you can see here in the screenshot, we got 4%. Depending on where you are in the country and how your losses are, not country, in North America. So you might have more snow loss in Canada. In the Southwest, you may have more soiling issues, meaning that dust may hit the array. It may rain on that, make mud, slurry type material on the panel, and eventually kind of create a little bit of a film, I guess I can say. I really kind of call that like a car. You know how like you can take your car to the car wash and just keep running it through the automatic all year long, but it eventually has a film on it that you need to wipe off by hand once a year. It's very similar to that. So that's if somebody ever asks about panels needing to be washed, no, not really, but you can. It would help a hair. Anyway, system losses are in there. There's also some information about how to calculate your total percentage. And then the tilt is affected. So remember that as the sun goes up higher in the sky in the summer, or the sun goes up higher in the sky in the summer and lower in the sky in the winter. So our tilt, our orientation to that is we kind of play the middle. That's why we go for either 20 or 30 degrees, likely 30 degrees. And we're going to aim for the shoulder seasons and get the average, the best position out of the entire year. And if you're going to be more aiming for more, if it's ground mount and you're needing more summer direct production, you might go for the 20 degree tilt. So it all just depends on the system design, on when somebody needs power. Then your azimuth as well again. So you're looking at this one, 180 degrees south, and then you can be east, west, but you cannot be north. North is just a complete waste of money.
Yeah.
So anyway, that's basically how you design a system, and it'll spit out how many kilowatt hours you need. You can talk about your DC to AC ratio. That's a field in there, and underneath the advanced parameters, and that's where you put your, if you're looking to be 125% or whatever. But like I said, John, let's just go to the next slide, and then if we're doing okay on time and not and we're being respectful of everybody's time, we can come back to this one at the end.
Sure, sounds good. So clipping, we want obviously to have clipping. This would be a cloudy day on the left here, sunny day on the right. And basically clipping is when you're producing basically more power than what the inverter is going to handle, which that's what you want. But and so on a cloudy day, you can see, we're not going to be producing quite as much, but there are peaks and valleys in there. So on the right side, on this sunny day, we're basically producing power, and then the inverter says, oh, I'm only at 10K. That's as high as I can really want. So we're going to level off there on your production. So you're looking at, here on a sunny day, 14.8 kilowatts DC on a 10 kW AC system. So that's when we're producing more than we're actually than what the inverter is. So on a cloudy day, obviously we're going to be producing a little bit less. So you can see kind of the peaks and valleys of the clipping situations. Is there anything you want to add to this, Kyle?
No, you did great.
Okay, excellent.
I heard you hesitate a little bit there. I wasn't sure. These aren't apples to apples comparisons. They're two different inverter companies. But I guess homeowners, just as a heads up on, again, back to expectations, I've had to deal with a few people that had systems installed over the winter that said, what is going on with my system? Why is it flatlining like that? Well, just be confident in the fact that we talked about the 125% rule or more. I mean, Fronius and SolarEdge you can put 150% on top of those inverters if you'd like. So if you have a 10 kW AC system, you can put 15 kW on it. In really nice days, you're going to have waste. I think we talked about that weather of, for example, Springfield, Illinois, and we have a third of the days out of the year are really nice days, and whatever percentage were also partly cloudy days, meaning that we have lots of cloudy days. And throughout the year's production, we're going to try to make as much kilowatt hours as we possibly can. So we just have to be prepared that on the days where it's really nice outside, we could be wasting DC energy going into the inverter. And on this case on the right, like you were saying, John, like you should have had more of a bell here, and at the top more rounded, but we've cut it off, and that's going to happen. We did have some waste that day, but throughout the year, we're going to be producing more kilowatt hours throughout the year to where it's worth it to waste it on the really nice days. Clear as mud?
Yep. So we'll move on to some ground mount sizing and design. And then next week, we will cover ground mount installation next week. So we're not going to dig real deep into the actual installation of it, but we will get a little bit about the ground mount sizing and design. Obviously, the sky's the limit. I mean, you can have a great big building with the whole roof is covered in panels. So the sky's the limit with the panels. You can put as many as you need. I know like the Apple building, the whole roof of the Apple building is nothing but solar panels. So the sky's the limit on that. As long as you've got the space available for the high kilowatt coverage. Again, the best performance is at a 30-degree angle on the racking. Take into consideration the DC wire distance run, max is 500 feet. And where you're going to locate the inverter. Is it going to be at the array? Is it going to be on your H stand, or is it going to be in the house, indoor or outdoor? The H stand is basically the power coming in, that AC power coming into your home. So
be on a pole or a pedestal, you know, or whatever else. Just I was trying to illustrate with that point there. That's just not on the house and not on the array.
Yeah. So make sure we know where you would like it mounted or where it's going to end up. Some of the ground mount options, we usually use 2 different manufacturers for the racking. We prefer the DW or the DPW. That's our preferred line. It's a very fast installation. It uses similar, and I'll show a picture of it here in just a second, but it's basically, it looks like kind of like an I-beam, and they can drive it into the ground. You can dig it in, dig a hole in the ground, put concrete in, however you want. But all the rows are only 1 post. And then it has like an arm coming off the bottom of it that'll hold the front end or the panels on the front of the racking. So it is the preferred method of ground mounts by the installers because it is a lot easier and quicker to install. And again, I'll show you a picture here in just a second on it. But on the Iron Ridge ground mount, with the DPW, the I-beams and some of the racking stuff can be a little bit costly to ship, especially if you got to go across the country. So it's basically a dedicated truck for the DWP line. So you're looking at, all that shipping cost. With Iron Ridge, basically they use a 2-post row with 3-inch pipe, but the pipe is supplied locally. So you would get that from, your local pipe supplier. So we lose that shipping cost. Basically the brackets and the mounting hardware you would purchase through us in Iron Ridge, and then you would supply the pipe locally. Basically there's 2 pipes in that row. So the beginning, the lower portion closer to the ground would be obviously your short pier, and then the taller one would be in the back. I've got again a picture of here coming up, but there's many configurable options, and it is good for some tight spacing. Basically, to the right here is a DPW racking system. Kind of looks like a little triangle down in here. You can see the I-beam and then the little, I don't know, cantilever or an arm coming off the bottom that'll hold the bottom for the racking. There also are post rows. Make sure we got top of pole, solar panels, and then I haven't really seen any of these we've installed, but there are tracking panels as well. There's manual, single axis, and dual axis. So single axis it'll spin, and then dual axis it'll spin and tilt. So it would, obviously look at where the sun's at kind of during that day and tilt it and spin it based on that. The problem a little bit with the tracking modules is that, it's just like anything else. It's got a motor in there and there's other things that could fail. So it's just cost-wise, it could be a little bit more costly for repairs.
And this slide,
the motor sooner or later will burn out on that tracking module.
The top or the dual axis may even have 2. So what we've seen is that anytime we've basically it's smart to do a dual axis tracking like this if somebody doesn't have roof space available, or new construction nowadays is all cut up and jagged roofs and roof lines and everything else, and it's really hard to get any modules up there. And then if somebody has a little bit of ground space available in an urban area, that's where this may make sense. But to be honest, I'm seeing a trend with us on solar pergolas, and call them like carport type designs where somebody can put a solar pergola in their backyard and they don't have to do this. So we've actually never even sold one of these, even though we have access to them. It's just, they just don't really add up to do, but there could be a case.
Yeah, there'll be a little niche, you know, maybe like Kyle was saying, in a urban where, you know, maybe they're in a townhouse and they don't have any space at all, so they have very little roof line, so there's something that, you know, may work for them. But it's just another thing that we offer to, you know, help you guys out and make sure we got all our bases covered. This is the Iron Ridge racking. So you can see the Iron Ridge will have the rails. They've got, I think it's like an XR 1000 rail, and then your posts and things will be the round piping. But you can just kind of see what the racking is. We'll get more into this Iron Ridge and the DPW racking next week. But we just kind of wanted to show you what some of the ground racking was, and we'll show you here some roof racking as well. This is the roof mount sizing and design. So this is a picture here on the right. This is from Aurora. So this is what Angelique and Jeremy work with daily on designing roof mounts. Normally, we're going to design the portrait for structural integrity and the cost of the racking. Obviously, we're going to have to know the angle and the pitch of that roof. You may have to bring in a structural engineer. I would definitely look into it if you've got, you know, you're going to have heavy snow load, because we're going to have to take the snow. The roof should be able to handle the snow load, but we need to make sure that the roof can handle the snow load and the weight of the solar panels. So if you're ever in doubt, definitely bring in a structural engineer and take a look at it. Obviously, you're going to have to understand the rail span and how long it can span. There are through Iron Ridge, and I'm not quite sure on DPW, but that will actually list some spanning and how you can span rails and mount panels on it, overhangs, things like that. So there's definitely some charts. We'll kind of cover that a little bit more next week when we're actually installing the ground mounts. Obviously, energy conservation is critical for roof mounts. If there's not enough room on a roof for a full coverage, I mean, a lot of these roofs are cut up, and you can kind of see this picture over here, how it's really cut up. But so with a roof mount, if we don't have enough room on that roof, we want to try to conserve as much energy, you know, that we can, so then maybe we can fit all those panels up there that will supply the home. Because we would really hate to do like a roof mount and then a couple panels on the ground, or, you know, something like that. So if we can conserve more energy, we might be able to get all the panels on the roof to supply the power. Again, some roof racking options. We have rail racking, and we have railless or rail free. So on the left here is an Iron Ridge roof mount with rails, and then Rooftech actually has the railless, which is some brackets, and you actually mount the brackets right onto the roof, as seen in those pictures there on the right side.
This one, I threw these pictures in there on this slide, and I couldn't find any I really wanted, or, you know, I was able to zoom in here, so I apologize, but that is not a rail. I want to clarify on the railless, rail-free side with Rooftech. That is like that's what they call a skirt. So that's optional, but there is a, I guess a trend, I guess I'll call it, with as solar installers move forward, they're starting to like rail-free and a railless, because as long as you get, I mean, there's tolerances there, but as long as you get your layout done and applied correctly to the roof, there's a whole lot of savings that can be made with rail free. I don't really necessarily have any concerns with doing it by any means, other than it's new. To me, it's been around for a long time. It's just not my, my personal forte yet. And we have a little bit to learn on it, but it seems the more we learn, the more that we like it. And, shipping costs greatly drop. They can handle heavy snow load with rail free. So if you don't, basically, like Roof Tech, we're working on going through our distribution, train the trainer, if you will, training with them. And they showed us some images of, a full truck bed, a full semi flatbed